Hey everyone, welcome back to Game Developer Unity. Today, we are diving deep into the solid principles, a set of 5 design principles that can help you create better, more maintainable, and scalable code in Unity. For Unity game developers, these principles are especially valuable in large and complex game projects, enhancing the manageability of code and saving time and effort in the long run. Whether you are a beginner or an experienced developer, understanding these principles can significantly enhance your game development workflow. So, let's get started. What is SOLID? First, let's briefly explain what SOLID stands for. SOLID is an acronym that represents 5 design principles. 1. Single responsibility principle. 2. Open-closed principle. 3. Liskov substitution principle. 4. Interface segregation principle. 5. Dependency inversion principle. These principles were introduced by Robert C. Martin, also known as Uncle Bob, and they're aimed at making your code more understandable and easier to maintain. Single responsibility principle. Let's start with the single responsibility principle. This principle states that a class should have only one reason to change, meaning it should only have one job or responsibility. For example, in Unity, if you have a player class that handles player movement, health, and inventory management, it violates single responsibility principle because it has multiple responsibilities. Instead, you could break it down into separate classes: player movement, player health, and player inventory. This way, each class has its own responsibility, making your code cleaner and easier to manage. Open-closed principle. Next up is the open-closed principle. This principle states that software entities should be open for extension but closed for modification. In Unity, you can achieve this by using interfaces or abstract classes. Imagine you are developing a game with different types of enemies. Each enemy might have a different way of attacking. To apply open-closed principle, we can create an abstract enemy class and derive subclasses for each enemy type from this class. The enemy abstract class defines the common properties and behaviors of all enemies. The attack method is an abstract method that defines the attack behavior of the enemy. The zombie class is derived from the enemy class and implements the attack method according to its own attack behavior. The alien class is also derived from the enemy class and implements the attack method according to its own attack behavior. Open-closed principle allows for the extension of existing code without modification. For example, if you want to add a new type of enemy, you do not need to change the existing enemy class or other enemy classes. You can simply create a new class and derive it from the enemy class. This increases the flexibility of your code and facilitates future changes. Liskov substitution principle. Now let's discuss the Liskov substitution principle. Subclasses should be substitutable for their base classes. This increases the flexibility of dependencies between classes. Suppose you are developing a game with different types of enemies. All these enemies can attack, but their attack styles are different. To apply Liskov substitution principle, we can create a base enemy class and derive all our enemies from this class. The enemy class defines the common properties and behaviors of all enemies. The attack method is used to make the enemy attack. The zombie and alien classes are derived from the enemy class and each implements the attack method according to their own attack types. Liskov substitution principle enhances the extensibility and flexibility of your code. For example, if you want to change how enemies attack, you only need to modify the relevant subclass. Additionally, by using a variable of type enemy, you can refer to any type of enemy in your game and call their attack method. Interface segregation principle. Moving on to the interface segregation principle. This principle suggests that clients should not be forced to depend on interfaces they do not use. Suppose you are developing a game with different types of characters. Some characters can fly, while others cannot. To apply interface segregation principle, we can create separate interfaces for characters with and without the ability to fly. The iFlyable interface defines the fly method that characters with the ability to fly must implement. The non-flyable interface defines the walking ability for characters that cannot fly. The bird class implements the iFlyable interface and has the ability to fly. The human class implements the non-flyable interface and has the ability to walk. Interface segregation principle makes your code more modular and flexible. For example, if you want to add a new flying character, you only need to implement the iFlyable interface. This prevents the implementation of unnecessary methods and enhances the understandability of the code. Dependency inversion principle. Finally, we have the dependency inversion principle. This principle states that high-level modules should not depend on low-level modules, but both should depend on abstractions. This reduces dependencies between modules and increases the flexibility of the code. Suppose you are developing a game and you need to manage player inputs. Player movements can be controlled with a keyboard, gamepad, or touchscreen on mobile devices. To apply dependency inversion principle, we can define input management with an abstract interface and implement this interface for different input managers. The input manager interface defines a method to get movement input. The keyboard input manager and gamepad input manager classes implement the input manager interface and get movement input from different devices. The player class depends on the input manager interface. This means that we can easily swap different input managers into the player class by injecting them. Dependency inversion principle increases the flexibility and testability of your code. For example, if you want to port your game to different platforms, you only need to change the required input manager. Additionally, by depending on the input manager interface, you can easily test the player class with different input managers. To wrap up, the solid principles are essential guidelines that can greatly improve your Unity projects. By applying these principles, you'll create code that's easier to understand, maintain, and extend over time. If you found this video helpful, please give it a thumbs up, subscribe for more game development content, and let me know in the comments how you apply solid principles in your projects. Thanks for watching, and happy coding.